Hi, my name is James Hutchinson, and today we're going to be doing some geometry. That's not the one with the rocks, and it's not the one with the maps. It's the one with the shapes. You know, so basically, what we're going to do is we're going to figure out the volume of a tank. But before we do that, let's do a little crash course. All right, this distance, one measurement, that's 20 inches. Okay, one line. That's the most basic thing. Very easy thing of measurement. Now picture this piece of paper is area. Like you might use area, which is length times width. Use that to figure out how much property you have in square foot, something like that. Now, volume is area, only three-dimensional. How much you can hold in there. And that's what we're going to be working on today. And let's see, these are easy, Area of the square, that's length times width. This is length times width times height. That's the volume of your box. But unfortunately, everything's not square. So we have to figure out more stuff. That's where pi comes in. Pi is basically a magic number for figuring out measurements with circles. And this isn't all of pi. This is an approximation because actually pi is a very unique number because it keeps repeating on and on and on and on and on. And like, I don't fully understand pi. I understand that pi works. Okay? And now, what we're going to do is we are going to just figure out how much liquid we can put in this tank. And now, you see we've got the tank. It is 28 foot from here to here when it starts at its round ends. Okay? And from where it starts rounding off is 7 foot here and 7 foot here. And I did not draw this to scale. It's a lot better in the book. From here to here is 14 foot. Okay? Now, I don't know any kind of easy way to figure the volume of something shaped like this. I don't know the formula. But what I do know is I got this here, I got this here. This is a cylinder. Now you got to picture it's round, like that. It's round. And so what we can do is, if we know how to calculate a cylinder, we can take that off. Okay. Now, the formula for a cylinder is volume equals base times height. Like, they explain it like that. So, to make it easier for you to understand, we'll turn it vertically. And that might help you out. Base times height. Alright. Now, what is base? Base is, imagine that's the measurement you want, the flat of the circle. To do that, you're going to have to take a formula you've probably heard of, like even if you don't understand it, pi r squared, even though we know they're all round. But I know the lame joke has been done too much. But pi r squared is the formula to figure out the area, which I say that's the flat measurement of circle. So basically, take this number here and take pi. Get our calculator because it's always better to work it like that. I'm going to go 3.1416. Okay. So what is R? R stands for radius. Radius is radius is half of diameter. What is the diameter? It's the distance from one point of the circle to the other side. Which our diameter for this is 14. So if you cut that in half, you're going to get your radius. That's going to be 7. Okay? So we have 3.1416. And I tried to work out a mnemonic device for everybody to remember, but I got to March 14th was the day that Karl Marx died, and it's 2016, but I figured that'd be obsolete next year. But, so we got our pi in there. I'm going to go times 7 times 7, because that's what r squared is 7 times 7. Alright. And I'm going to keep better track of these numbers, because I've tried to do this video before and I lost the numbers halfway through. So what that is 153.9384. That is the square feet of the base. And then, like I said, you take that and you multiply it times the height, which is actually the width in this situation, but it's 28. Alright, and we get, that number is 4310.2752. Alright, what that is that is the cubic feet in this area, from here to here. I'm going to cut it off. The red has been done. Alright, now we've got the blue out there. And see, I was looking at, when I was looking at the problem in the book, it took me a little bit to realize that these are the same size and they're coming out and they're a perfect circle. Okay, or not a perfect circle, but a perfect sphere, which is a three-dimensional circle. And once I realized that, I could use the formula for figuring out the volume of a sphere and just pretend none of this matters. Okay, so we've got our measurements, hopefully. Now I'm going to show you something, and it tripped me up because they give it to you real simple. It seems simple when they write the formula out. I'll show you. You'll see what I mean. Alright. Now the volume of the sphere is V equals 4 over 3 times pi times r cubed. Alright, because see, we're figuring out a three-dimensional thing, so that's why we're doing it in cubes. Alright. I looked at this and I'm not a very good math person, so whenever I saw how they wrote it out, whenever they filled in the actual numbers, it fills out like this: V equals 4 times, and see, I'm gonna have x's here, but there's no variables. Alright, sorry for the delay, but it's 4 times 3.1416, and I repeat that so many times because it's good, to hear it, and you'll learn it. And the radius, since it was 7, and together there's 14 across, 7 is the radius on this too, and that's cubed, so there's 3 of them, so it's 4 times 3.1416 times 7 times 7 times 7 divided by 3. Okay? And that's what we have there. Now, since I'm using a graphing calculator, I prefer to type it in and then divide it after we get it, because it all works out with the order of operations. So that'll be 4 times 3.1416 times 7 times 7 times 7. Alright, now that we've got 43102752, okay, the same number we have there, we're going to divide that by 3, and that gives us 1436.7584. Okay, now we've got all the volume. Okay, so let's get a little bit more room here. Now this is an easy part. Next step is adding. So we know this is our volume for the cylinder, and this is the volume for the other. So we're going to add 1436.7584 plus 4310.2752. Okay. Now 5747336. All right. That's what we got when we've added it all together. Now, one of the parts that I left out is nobody in the oil and gas industry wants you to give them a measurement in cubic feet whenever you're measuring liquids. So, I'm going to check my measurement real quick. The measurement we want is barrels. And that's denoted as BBLs, barrels. And like I said, a lot of people get it confused because all of the barrels of stuff we see are actually drums that are 55 gallons. I think, no, but it's 42 gallons in a barrel. Okay? But there are 5.61 cubic feet in a barrel. So that's what we're going to work with. And it's real simple. We're just going to divide it 5.61. Alright, we'll do that on here. And we get the total 10244267. Alright, it went on a little bit longer, but we can or you can go with, you can round it off wherever. You can go 102443. Yeah, that's what we'll do. We'll do that. And I'm pretty sure that's what's going to match the answer in the book. But that is 1024.43 barrels of oil can fit in this tank. Alright, and thank you for putting up with my long-winded, off-the-wallness, and y'all have a good night.